as you can see, I'm already inspecting my virtual machines. The last time we tried to complete this mission about compiling, and running tests on Bitcoin Core, we failed last time because we had a machine with not enough memory, and the time before we tried to use the e-micro machines, which do not have enough computing power, I think. Not sure, but I suspect that was the case. So this time we are going to set up things differently. Let's see if we can use directly at 2 virtual CPU, or maybe a 4 virtual CPU with 16 gigas memory, which will account for 14 cents per hour. Therefore, I will say to select this one, and here I will change the disk size. I will put, like, let's say 60 gigas. I mean, 20 should be enough, but I just want to be sure. Let's say 40. So with 40 balanced persistent disk, 40 gigs of balanced persistent disk. Let's see with SSD, how is it going to change? It's not changing, so I will put 100 gigas, let's see. And yeah, in this case it's changing, so I will put 60. Let's stay on 14 cents per hour. 15, okay, 15 is acceptable. Networking, we did not have any issue with networking until now. Therefore, I will just launch operations on this setup. Let's see if we put if the cost will increase a lot. Oh yeah, it's doubling the cost, of course. Yeah, let's go then. Let's see, advanced configuration. Let's just create the machine, and as soon as it gets created using the instruction in this article by John Attack, we'll install all these dependencies, and yeah, then we will be able to compile, to clone and compile the code from Bitcoin Core GitHub repository. Okay, so now we have this ready. Let's update the packet manager. So the apt-get update. Otherwise, it will not be able to retrieve all the packages. We're going to ask to install with this command. This may take a minute or more, as there are a lot of packages. So for this machine, I did select just a normal networking configuration, as we will not do anything particular with other than downloading these packages. We will not do a lot of networking activity. Okay, so everything is unpacking at this moment. Sometimes it may be boring as we're repeating this operation for yeah, it's like the 10th time I'm downloading these packages, but it looks like it's something that one has to do many times when creating environments for developing until we get the right setup. So during the last videos, when we already tried this operation, we have been through all these libraries which have been installed now. We have seen what they're about and why they're necessary. Okay, so let's clone the repository. So we're in our home folder. We're going to clone it, and a Bitcoin folder will be created. So we are downloading the repository now. This takes less than a minute usually. After that, we basically have to go in the folder, and here we have to list all the branches that we have, and we have to select on which branch we would like to work. Oh, sorry. So instead of tag, we should go with v28.1. So it's giving you a notice about this change. Now before we did this checkout, we will not have been able to see this autogen.sh. It has been copied here because we checked out this branch, this specific branch. Now we need to select the autogen.sh, execute it. Okay, so here now we have some files which will then use for compiling our executables. Now we first run this configure thing here, which will configure basically our compiling environment, and without any tag like this, it will prepare everything to be configured for by default with GCC. Then I would like to try to configure the compiling environment to work with CLang. Okay, so here we have like an output which states how the build options have been configured. Yeah, we have other logs which may be interesting after we we get confidence with this works. Okay, so now we will run a make command, specifying that we want to use our all our cores, so we basically obtain the outputs faster. This is the operation where all the other times we had issues, so I hope this time it completes successfully. Let's see, let's hope. Sorry. So okay, for now it looks like it's running. We'll see. I will mute myself and I will wait for this operation to conclude. Okay, so now this looks like completed correctly, and let's have a look. Now we shall be able to complete the next steps. So these are other configurations for the compilation things. To compile for FATS testing, build with Clang using the following. Okay, so FATS testing will be something we'll try after. To compile with sanitizers. Yeah, again, something with Clang. Okay, make check. Let's see one thing. So let's see exactly the difference. Oh my god. Login. Or try it first. Is it possible to try it? Yeah. Come on. What's happening exactly? Oh, fuck you, ChatGPT. So, new chat. So this will be my question in Linux. The make command has a version that's company that has another. Okay, so what's the difference between make and make check? Okay, so I need to figure out the difference between make and make check in Linux. Let me start by recalling what I know about the make command. Make is a build automation tool that compiles source code into executable programs. It uses a make file to determine how to build the program. When you run make, it looks for the make file in the current directory and executes the default target, which is usually to compile the code. Now the user mentioned the parameter called check with make, so make check must be a specific target in the make file. But what does that target do? I think some projects include a check target to run tests after compiling. That way, after building the software, you can immediately test if it works correctly. So maybe make just builds the code while make check builds it and then runs the test suite. So okay, this is something intuitive. Wait, but does make check rebuild the code every time? Oh, nice question. Or does it only run the test if the code is already built? Great question. I should check how make files work. If check target depends on the compiled binaries, the make check will first ensure everything is up to date and then run the test. If the code hasn't changed since the last build, it will just run the test without recompiling. That makes sense because it's efficient. Also, not all projects might have check target. It depends on whether the developers included it in their make file. So the presence of make check is project specific. Some might use make test instead, but the user is asking for make check specifically. So the main difference is that make compiles the code and make check runs the test, possibly after ensuring the code is built. Another thing to consider, sometimes running tests might require additional steps like generating test data or setting up an environment. The check target will handle all that. Also, some projects might separate building and testing, so make alone doesn't run tests. This helps in situations where you want just to build once the test multiple times. I should also mention that make check is commonly used in automated build system. like when using continuous integration, they build the code and then run tests automatically. So summarizing the key differences that make builds the project, while make check runs the test, which may include building if necessary. Okay, so DeepSeek touched all our interests, so we'll use this multi-threading command, multi-threading version of make check. And let's see. I'm not sure if it will work at first try. Okay, so it's actually running the tests. All of these tests have been written by people that deliver the code. Test to summary for Bitcoin Core 28.1.0. Total tests pass. Okay, so we did not have any error for this suite of tests for Bitcoin Core 28.1. Let's see what else do we have in the outputs. There are a lot of tests, so I'm imagining that there will be they will take a long time or not. Okay, so they're continuing. I will just mute myself, and when all of these tests finish, I will comment the output.
Celebra este San Valentín y expresa tu amor con un regalo especial, solo en Douglas.
Ahora puedes vender electrónica de segunda mano en Vinted. Deshazte de lo que no usas, desde teléfonos.
Okay, therefore now we have a good situation, I would say. All the tests have been successfully passed. Let's see. So as we have seen, we have this specific test suite summary for Bitcoin Core 28.1.0, which is the version we decided to work on and to build. Then we have another test suite for libsec, which is the library that helps with all the encryption tasks. Yeah, this is specifically like the library built for the specific elliptic curve used in Bitcoin cryptography. Okay, therefore it looks like we have done them. Now run the functional tests. Let's see. So Jonathan at this point in his article is advising to run the functional tests from the repository root. So test functional test runner pi to run the standard test suite. Let's just check what we have here. So it says to go to test. Oh, sorry. And then here functional tests. Test run p. So to run the standard test suite, we can try also with this parameter or a similar high number to run the test more quickly in parallel. And to run an individual test file. Okay, so we just choose one. To run the extended test suite to see the various options for running tests. Okay, so here we have more infos. Let's see this version here. I will check this one, which looks like no such file directory. Of course, we are already in test. So let's see. Yeah, let's go. Therefore, temporary test directory at tmp test, blah blah blah. So what's happening here is that it looks like, yeah, that they're checking what has been compiled and not. So some tests are being skipped because we, for example, do not have this. We did not compile everything, which may be necessary for legacy wallets. Okay, so it looks like we have an error. Let's see. Okay, so there was an error with If this failure happened unexpectedly or intermittently, please file a bug and provide a link or upload of the combined log. Yeah. So this looks like that we have some instructions when a test fails. For now I will ignore them, as I don't really know why they're happening and what I should do. However, yeah, it's interesting to know that you may have this type of logs basically. Hey, sometimes we have some funny things. This looks like a test for a long input. Jesus Christ. What's exactly import private miniscript descriptor? Broadcast and transaction. Wow, there's so much code here. So I imagine that after this experience, now I should maybe read a bit about all these options here, and then how to contribute to pull request to Bitcoin. Yeah, maybe I will read this, but the really interesting one is this one. So let's see here, how to review the pull request in Bitcoin, built on the foundation laid by how to review. Okay, remember that testing issues and reviewing are the most effective ways you can contribute as a new contributor, and will teach you more about the code base than opening PRs. Okay, so yeah, I'm just reading these. I mean, it says it's based on this one, so it doesn't even make sense for me to start from here. I will start from this. So reviewing pull requests is the best way a beginner can contribute to the Bitcoin Core repository in GitHub, more than opening new pull requests. So instead of directly modifying the code, it's better to study what other decided to propose as modification, and understanding all the process involved in reviewing will teach me more than actually writing code, as in the end I will have to analyze way more code than I can imagine writing it. So yeah, I will go for reviewing activities. So let's see, this article has some chapters. We have this guide built on the foundation laid by these presentations. Nice. I will have a look at this. Let's see where I can find this material. Okay, contributing to Bitcoin Core personal account. So let me add all these things here. I will create a subfolder called contributing and of course John Attack will go into contributing, also him, and this one, which I'm not sure why it's appearing only like that.
All right.
Okay, so we have also YouTube video. Okay, and we have only 465 views. Man, this is bad. But yeah, so let's see. San Francisco cryptocurrency devs. Most viewed video is this one. Algorithmic program secure smart contracts. What the fuck is this? Interesting stuff, I mean. And the latest video is 5 years ago, so it's not an up-to-date channel. Okay. In any case, it looks like we have many interesting conversations here. Nice sources. And this looks like, yeah, I can read it all. Okay. Understanding the technical side of Bitcoin, yeah. Okay, wow, command line. Interesting. So there are some other resources. Okay. So a gentle introduction to Bitcoin core development. So you want to be a core developer. Okay, so we'll have read of this article, but first let's see if we finished all of this. Okay, so some tests failed, but the major part passed. So what does this mean? I'm not sure, we'll discover it later. For now, I will stop here. So today we finally successfully compiled, built, and executed the tests for the Bitcoin Core code. One other curiosity. Oh, so let me reopen here, because I have another curiosity now. I would like to see if I can actually execute the Bitcoin D daemon. So let's see, what do we have here? Okay, nice. Then once I built and tested my code, where can I find the outputs? We talk about C++, Bitcoin Core, where can I find, for example, the Bitcoin D executable? Can I run it as it is, or do I need something more to obtain the actual program that is used by a normal user, let's say, which wants to run the client? Okay, let's see. Oh, sorry. So I was here. I wrote a pretty long question. So can you see? Yeah. Okay, let's break down the user's question. They successfully built and tested Bitcoin Core using make and make check. And now they want to know where the executable files like Bitcoin D are located. They also ask if they can run it directly or if there are additional steps needed for a normal user to use the client. First, I need to recall the typical build process for Bitcoin Core. From previous knowledge, when compiling software with AutoTools or similar system, the compiled binaries are usually placed in specific directories. For Bitcoin Core, the default build directory might be in the SRC folder or of the repository. The user mentioned C++ and Bitcoin Core, so I should focus on the standard path where the build outputs are stored. Common locations include SRC, SRCQT for the guy, or perhaps a separate build directory if they did not out of 3 build. But since Bitcoin Core's documentation uses just in 3 builds, the binaries are like in SRC. Let's have a look at this suggestion. So we are here in SRC, and let's go. We have all these .o files, which are actually the files we were looking for. And here we have Bitcoin D, which is the executable that allows us, for example, to run a full node and all that stuff. Next, the user wants to know if they can run Bitcoin D directly. I should confirm that once the executable is found, it can be run as is, but there might be dependencies or required configurations. For instance, Bitcoin Core requires a bitcoin.com file and data directory. New users might not be aware of this, so it's important to mention initial setup steps like creating configuration files or using command line arguments. Also, the user might be confusing the build output with installed system-wide binaries. When you run make, the executables are in the build directory. To have them system-wide, they need to run make install, which copies them into a standard paths like user local bin, but for testing, running from the build directory is sufficient. Oh, okay, so this is something I was ignoring. So if now I make install, I should have Bitcoin D available then. Another point is the difference between the build executable and the actual program and normal users. Normal users typically install Bitcoin Core via packages like apt, which handle placing binaries in standard location and setting up services. But when building from source, the user has to manage this themselves, either by installing or running directly from the build directory. I should also consider mentioning dependencies. Even though make compiles the code, sometimes runtime dependencies are needed. However, Bitcoin Core is statically linked for most parts, so the executable might be self-contained. Possible pitfalls: the user might not find the executable if they're looking in the wrong directory. So lastly, guiding the user initial runs to the running Bitcoin daemon to start, explaining about the data direct configuration and how to interact with the client using Bitcoin Click. Okay. Check the build. Can you run them? Yes. So you can run them like this. So the make command compiles the code, but install Bitcoin system while like a prepackaged binary you need to run sudo make install. This installation is executable to standard system paths, making them accessible globally. Therefore, first time set up for normal users. Even if you run Bitcoin D directly from the build directory, Bitcoin Core needs to initialize data directory. Download the blockchain. Yeah, okay. Example workflow for a new user. Build outputs, run directly from there. Unix build nodes, cmake build. Okay, therefore, if we run make install, say Bitcoin D. Permission denied. Okay, didn't see it. Why? So sudo make install src. Okay, now I think it's executing everything as expected. Nice. Therefore, in theory, we have Bitcoin installed. I'm not sure if everything is here. We can check and run Bitcoin D. Actually, let me see. I mean, I can just run it, Bitcoin D. So yeah, it's running. Nice. Therefore, in this video we cloned the Bitcoin repository from GitHub. We installed all the necessary libraries, then we chose a branch from the repository, and finally we started the compilation, building and test of the branch we selected. And after that we actually installed the compiled software. Now as we started Bitcoin, the daemon which executes all the services necessary to run a node, we actually have started downloading the blockchain. Therefore I will stop here, as I don't want to run a node in this moment on this machine. So thank you very much. I will just clean this mess and see you next time. In the next video I will start a bit, so I will bring you new interesting stuff.